you once again in class of 11th standard, giving you the notes about viscosity today and telling you what is there is in this viscosity. The coefficient of viscosity for a fluid is defined as the ratio of strain stress to the strain rate. Okay, so strain rate is what V upon L and strain stress is F upon A. That is F into L upon rho upon A, and this is called eta. This is called eta. Yes, it is pronounced as eta. So eta upon is equal to Fl upon Vk. Okay. So unit of viscosity is Poissonian Pi, and units other units are Newton second meter raised to -2 and PAS Pascal. The dimension is ml raised to -1 and t raised to -1. So this is how the layer of the liquid sandwiched between the two parallel glass plates, in which the lower plate is fixed and the upper plate is moving to the right with the velocity. So this is moving and this is already fixed here. Okay, between the two plates have been given, and thus it has been changing, or it is moving, or the lower part is fixed. The lower part is fixed and the upper part is moving with the right velocity, with the velocity v itself, and the force is given F. Okay, with the F of force itself. So let us start what is it called in thoroughly. Okay, so let us see. Most of the fluids are not ideal one, and some offers resistance to motion. This resistance to fluid motion is like an internal friction analogous to friction when a solid moves on a surface. It is called viscosity. So most of the fluids have their ideal one and offer some resistance to motion, and the resistance to fluid motion is like an internal friction analogous to friction when the solid moves in a surface, and this is what we call viscosity. So this force exists when there is a relative motion between the layer of the liquid, and suppose consider a fluid like oil enclosed with the two glass plates is shown in the figure. The bottom is fixed and the top one is moving with a constant velocity related to the fixed plate. The oil is placed by honey. A greater force is required to move the plate with the same velocity. Hence, we say that honey is more viscous than oil, and the fluid is constant contact with the surface of the same velocity as that of the surface. So we are taking the honey, and with the honey, the viscous force is being given to this particular plate itself, whose bottom part is fixed and the upper part is moving. So the fluid is contact with the surface has the same velocity as that of the surface. Hence, the layer of the liquid is contact with top surface moves with the velocity v, and the layer of the liquid in contact with the fixed surface is stationary. The velocity of the layer increases uniformly with the bottom at the top velocity v and bottom at zero velocity. At any value of liquid, its upper layer pulls it towards, with lower layer upward pulls it backward. This results in the force between the layer, and this type of flow is called the laminar. The layer of liquid slide over one another as a page of a book do when it is placed flat on a table and the horizontal force is applied to the top cover. When a fluid is flowing in a pipe or a liquid, then the velocity of the liquid layer along the air of the tube is maximum, and this hence decreases as we move towards the wall, where it becomes zero. The velocity of the cylindrical surface or inner tube is constant. On account of this motion, a portion of the liquid which is at some instant has the shape ABCD, like the shape of AEFD, as shown in the short interval of time del t. During this time interval, the liquid has undergone a shear strain of del x upon L, in which the strain is the flow of the increasing with time continuously. Unlike a solid, with the stress is found experimentally to depend on the rate of change of strain and the shear rate, that is del x upon L del t, or V upon L instead of strain itself. The coefficient of viscosity for a fluid defined by the ratio of the shearing stress to the shearing strain rate, and the unit of SI unit of viscosity is Poisson, and its other units are Newton second meter raised to minus 2 or Pascal per second, Pascal into second, and the dimension of the viscosity is ml raised to minus 2t raised to minus 1. Generally, this liquid like water, alcohol, etc. are less viscous than this thick liquid like coal tar, blood, and glycerin, etc. The coefficient of viscosity for some common liquid listed in the table 10.2. This points out the two facts about the blood and the water that they find interesting in the table, indicating the blood is thicker, more viscous than water. Further, the relative velocity eta upon eta n, eta water of the blood remains constant between 0 degree centigrade to 37 degree centigrade. The viscosity of the liquid decreases with temperature, while it increases in the case of gases. So in the liquid it decreases with the temperature, viscosity will be decreasing with temperature and increases in the case of gases, because in the cases of gases this particular temperature is being used for increasing the temperature when it is being changed into a gaseous, from a liquid to the gaseous state itself. So this is how this layer has been given. This second is velocity distribution for viscous flow in a pipe. So this particular thing is the velocity distribution for viscous flow in pipe, and this is the liquid sandwiched between the two layer glass plates, in which we have taken honey and oil, dropping in this particular field, and it is moving like this. This plate is fixed and this plate is moving. So it will be more viscous in case of the liquid such as more viscosity in case of other liquids which are more viscous than that of oil, and in the case they are less viscous than the less viscous, it will move very easily. So this is what we call the viscosity, and some of the viscous fluids are given in your table: water, blood, machine oil, glycerin, honey, and air. So viscosity limit has been given in your book itself. Please go through this thing. Normally we use the formula, this particularly it is given by Fl upon velocity into A. V into A, and this particular relation will come as a numerical to solve this viscosity limit. So looking forward for the next video in the next week itself. Till then, take care, and please, if you have some doubts or any queries, you can comment in the comment section, or you can directly WhatsApp me in the group which we have for 12th standard, 11th standard. Thank you, students.